Zero.
Zero. All right. Whenever, how about H2 molecule? What? H2 is
zero.
zero because it's by itself. How about O3, ozone? Again, zero. How about P4? What I'm trying to say, if you have an element by itself, then what's the oxidation number? S8. All of these compounds are known, and the oxidation number in all these elements are zero, simply zero. Clear? When they are with something else,
Can you repeat?
whenever you have an element by itself, any element, sodium, chlorine, H2 gas, O3 gas, P4, S8, or anything, whatever. I mean, there isn't such thing, but let's say we have carbon 4 or Br2. What's the oxidation number in all these elements? What's the oxidation number? All of these.
Zero.
Zero. Why? Because it's element by itself. Clear? Now, when sodium lose an electron, it becomes sodium plus electron. What's the oxidation number of sodium, of this sodium?
One.
Plus one.
Plus one.
What's the oxidation number of this Na? It
Plus
is
one.
Zero.
Zero.
Still zero. How about this one? What's the oxidation number?
Plus one.
Plus one.
Excellent. All right. Now, if I have Cl2 goes to 2Cl minus plus, and of course it needs 2 electrons. What's the oxidation number of this chlorine?
Zero.
Zero, because it's by itself. What's the oxidation number of this chlor ion?
Minus two. Minus one.
Minus 1. It's only
Doctor.
minus 1. Clear?
دكتور.
Yes.
So it is the يعني ذا الرقم هو الشحنة حق النواة.
Again.
يعني الأكسيديشن نمبر هو الشحنة حق النواة.
Not النواة. That's what I was thinking. It's الشحنة حق الأتم. الشحنة حق الأيون. Not النواة.
عدد التأكسد هذا.
عدد تأكسد. Yes, it is عدد تأكسد, and it is the oxidation number of the ion, not the nucleus. You say the nucleus. No, it's not nucleus. It is the ion. Okay, good. How about O2? What's the oxidation O2?
Zero.
Zero.
You are muted, doctor.
How about O2 minus?
Minus one.
No.
Minus two.
Minus 2. Look at the oxidation number from here. Is this clear? All right. Good. Let's clear all this now. Okay. Let's start. Now, if you have a compound, like, for example, NaCl, then what's the oxidation number of sodium? It's +1. What's the oxidation number of chlorine? Is -1. Clear? Now I want to define the oxidation number of every compound, in every compound. Like, for example, if I have, I will give you rules. Any element that contain, any compound that contain fluorine is always -1. Write this and don't forget it. Always -1. Oxidation number. Always, only fluorine is -1. I did not say chlorine or anything else. Okay, alkali is always what?
+1.
+1.
Very good. Alkaline
+2.
+2.
always +2. Oxygen or hydrogen first. Let's do with hydrogen.
+1.
+1.
+1, except if it is with alkali or alkaline, it will be -1, special case, -1 with alkali or alkaline element. Clear? So what's the oxidation number of H2SO4? What's the oxidation number of hydrogen in here? Only hydrogen. What is it? Always what?
+1.
+1.
+1, always. Except if we have an AH, then what's the oxidation number of H?
It's -1.
-1 when it is alkali or alkaline. Is this clear?
Yes.
Good. How about
Yeah.
last one? Oxygen. Oxygen is always -2, except if it is with hydrogen. I mean, except with
Peroxide.
peroxide like this. Or when it is superoxide, they call it also. When alkali, it become like this, then it is with superoxide. And this is clear now. What's the oxidation number of K? K is alkali. What's the oxidation number?
+1.
+1. So you know this is +1. So what's the oxidation number of this one? The total number for the whole compound must be 0. So in this case, O2 become what? -1. The whole O2 is -1. So it is -half to each oxygen. How about here? We know that hydrogen is what? Hydrogen is what?
+1. +1.
We have 2 hydrogen. This means what?
+2.
+2. What's the oxidation on O2? In O2. This means it is -1 each. That's it. I want you to memorize these only.
Doctor,
Yes.
does hydrogen is involved in alkali group?
Hydrogen what?
Is involved in alkali group or not?
It's not part of alkali group. No.
Uh,
All right. Now, based on this, of course, other than this, if we have chlorine or fluorine only with alkali metal, then also chlorine will be always -1. Chlorine, fluorine, and iodine, but not if they are with these things. What I want you to memorize are these numbers. Don't forget, write them because I want you to answer. Other than that, you should calculate things. Okay, now, don't forget, fluorine is always what? -1. Alkali, +1. Alkaline, +2. Hydrogen, +1, except when it is alkali or alkaline, then it becomes -1. Oxygen is always -2, except when it is with peroxide or superoxide. Good, clear. Next, let's very quickly find what's the oxidation number of these compounds. Okay, good. Now, let's look at these compounds. I want to know what's the oxidation number of each element. Let's start with SO2. So with SO2, what's the oxidation number of oxygen always?
One.
-2, and we have 2 of them. times 2 is equal to what? Minus 4.
minus 4.
So
we need
what's the oxidation number of sulfur?
4.
4.
4. Got it? Good.
Yes.
How about NaH? Hydrogen is always what? Plus 1.
Yes.
Except when it's with what?
With alkali.
Hydrogen in this case.
Na's الكالي
Minus 1.
Minus 1. What's it then? Sodium.
plus 1
Plus 1.
Plus 1. How about CO3 minus 2? Quickly. What's O?
Minus 2.
Minus 2 times 3.
minus
Minus
6
How about carbon?
4.
Plus 4. Yes, why? Because plus 4 minus equal to 2 minus, which is this one. That's correct. Last question. N2O5. What's oxygen?
Oxygen minus 2 multiplied by 5.
Minus 5
minus
minus 10.
Minus 10.
So this must be plus 10. So we have 2 of them. This means each nitrogen is what?
5
Plus 5.
Clear? That's the oxidation number. Good. Now, we said that. What is this process called? What's this?
Oxidation.
What?
Oxide.
Oxidation.
Yes.
Why do we call it oxidation?
Because it's lose or gain
electrons
What's this
electrons.
process called? Copper.
reduction
Reduction.
Reduction. So we have both of them. What do we call this reaction? We call it. Read it. Redox. Redox. Why did you call it redox? Reduction, oxidation, reaction. Reduction, oxidation, reaction. So we have oxidation, we have reduction, we have redox, which is oxidation reduction, which is this total of these two. Don't forget, the number of electrons must be the same so that they will cancel with each other. So this must equal to this one to make it equal. Okay, now the zinc is also called reducing agent. Why? Because it will give the electron to the copper and it will reduce it. While copper, which has been reduced, what is it called? What? Oxidizing agent. So when zinc is oxidized or oxidation happened to oxidize, the zinc is a reducing agent. When copper is reduced, it becomes oxidizing agent, or it is oxidizing agent. So these two words, reducing agent, is related with what? Clear? And oxidizing agent is related with what?
reduction
Clear? I hope so. Good.
دكتور
Now, what happened here to this element? Okay, what's the oxidation number of hydrogen in this case?
0
Yes, very good. 0. Why? Because it's by itself. What's the oxidation number of this compound? F2.
Zero also.
Zero.
Also 0 because it's by itself. Exactly. Now, what's the oxidation number of F?
Minus
Minus
-1.
-1. Good. And hydrogen?
+1.
-1.
Plus
So
1.
let's ask you simple question. What has been oxidized?
Both.
No. What has been oxidized?
Fluoride.
هيدروجين.
Hydrogen has been oxidized. H2 went to H plus. So it loses 2 electrons. Clear? Because it was 0 and now it become +1. So this has been oxidized. So what's the other name for it?
It's a reducing agent.
Reducing agent. What has been oxidized? I mean reduced. On the other hand,
Fluorine.
F2, which was 0, went to what? F minus -1. And of course it needs 2 electrons.
Reduction.
And then this will make 2, and this will be reduced. So it is what?
Oxiding agent.
Agent. I hope it's clear. Good. Done with this. Now, displacement reaction. Which element will react with which element? Be careful here. Look carefully. When we put zinc solid to zinc chloride, what happened here? The zinc went. What's the oxidation number of zinc here?
0.
0.
0. It's written here. Why it's 0?
Because
But it's not losing or gaining any electron.
Because
It
it's
is
by
with itself.
alone. When it is alone, then it is 0. Good. Now, what's the oxidation number of zinc here?
2.
+2.
Plus
What happened to the zinc?
it lose to
Oxidized.
Oxidized.
Died. Okay, let's look at copper. What's the oxidation number of copper in this compound?
+2.
+2.
+2. What is it when it's by itself?
0.
0.
0. So what happened to copper?
Reduction.
Reduction.
Okay, good. So we find that zinc, if you bring a solution and you put zinc or copper chloride, CuCl in it by itself, CuCl2, and you bring a bar. This is a bar of zinc, and you take this bar of zinc and put it here. You will find gradually the zinc is dissolving and the copper is coming out as. Why? We call this displacement reaction. This means the zinc will displace the copper. Clear? But if you reverse it, if you put copper with zinc chloride, trying to displacement to make it copper chloride plus zinc, you will find that this will never occur. The reverse reaction will not occur. So which element displaces which element? We have. So if you reverse it, as I said, we see here, can you see the zinc displace the copper? It became, instead of, it was in solution and the copper come out as solid. But if you reverse the reaction, you will find what? No reaction. Which element will displace which element? We have this table, which I don't want you to memorize. Don't memorize anything in this table. But the one at the top will always displace the one at the bottom. Displace. So if you put lithium with anything, it will displace it. But if you put anything with lithium, it will not displace lithium.
What about fluorine?
Oh,
Fluoride.
this is only elements. This is only for elements.
Mhm.
Okay, for metal. The only exception is hydrogen. If you look here, they're all metal, and hydrogen is exception. Look at zinc, which we just did a while ago, and look at copper. Where is copper? Copper is here. This is zinc, and this is copper. So if you put zinc with copper plus, this means, what do you mean by displacement? This means if you take this element as it is and put it with the ion of the other element, which is copper, it will become, the zinc will be coming as ion, and the copper will go back to solid. This means the one at the bottom will be reverse reaction.
دكتور
What do you mean by reverse reaction? It will be the other way. Yes.
هل راح يكون مثلا في الاختبار راح يكون عندنا هالجدول؟
بالضبط. If I give you anything related to this, I'll give you the elements. Look here, what I want you to memorize, as I said, what do you see at the bottom? Lithium, potassium. Where do you see these? Alkali.
Alkali metal.
Yes, and alkaline, sodium, magnesium. All of these, alkali and alkaline, at the top. So these are called very active elements. And if I don't give you the table, but I give you any of the alkali or alkaline, where do you expect to see them?
Display other element.
Display other
They are
elements.
active.
All of these are alkali and alkaline, except aluminum. Aluminum also is very active.
So they lose electron easily, yes?
Easily, they can lose electrons easily. Exactly. Now, look at this. Which one is the last one? Gold.
Gold.
Which one is the next?
Platinum.
Platinum. Do you know what's platinum? ايش البلاتينم؟ اللي يسمونه الذهب الابيض. All right? Okay. Okay. What do you call these elements? We call them inert element. What's inert means? What's the meaning of inert?
Not active.
What is it?
Not
خامل.
active.
Not active. Inert خامل أو not active. Clear? Okay. What do you, actually ليش الجولد expensive? Why?
It does not interact with the other atoms.
Because it is inert, because it stays as gold, always. Clear? And that's why people like to have it. And platinum is also, يسمونه الذهب الأبيض. Also, because it is inactive. Look here, silver, الفضة, is also inactive. That's why these elements are expensive. And so if you have a reaction in which you see gold or platinum or copper or silver, copper in the same group, look at your periodic table, copper and silver and gold are the same group. Okay, these are inert elements. All right. Now, which of these elements will displace hydrogen? Which element will displace hydrogen? All of these will displace hydrogen. Which one will not displace hydrogen?
From copper until gold.
From copper to gold.
will not displace hydrogen. Clear? Of course, if we put lithium with hydrogen, how do you think the reaction will be?
Lithium will displace hydrogen.
Clear? All right. How about if I put lead with hydrogen? Lead with hydrogen. What do you think will happen?
Also, lead will displace hydrogen.
It will displace, but very, very, very slowly, or maybe it will not displace. Why?
Because both lose
active.
ions easily.
Close to each other. Clear? Very close to each other. Is this clear?
Yes.
Very good. I hope so.
But Doctor,
Yes.
how can I know that the reaction is oxidation and reduction? So I displace it. I replace the element. How can I recognize the reaction?
If I give you this reaction, is this oxidation reduction? Yes. Is this oxidation reaction?
No.
Yes. Yes, it is. Lithium went to lithium plus, and H plus went to H2.
Oh. Okay.
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 Is this reaction going to take place or not?
Lithium and hydrogen.
Yes.
Yes, it's going to replace.
It will replace it. Yes, it will replace it. If I say replace it, this means the first reaction, which is lithium, I keep it as it is, and the hydrogen, I reverse it. That's what happens. Now, let me ask you another question. If I put zinc 2 plus H2 gas, is this going to give us 2H plus zinc solid? Is this going to take place?
Yes.
Zinc 2 plus H2 to give 2H plus zinc. This will not take place.
No,
Why?
because the hydrogen is less active than the zinc.
More active than hydrogen. So the reverse will take place. So the zinc plus 2H plus will go to zinc 2 plus. Should go this way, but the less active should be reversed. Is this clear? I hope.
Yes.
Clear.
Good, good. So very quickly, is the first reaction take place or not?
Will take place.
Why?
Platinum is less active than
Platinum
iron.
is very inactive and iron is higher. So yes, will take place. What's the product?
FeCl2
Exactly.
plus P3.
FeCl2 plus platinum. Good. How about this one? Gold.
It will take place.
Yes.
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 Product.
CrCl3 plus A.
AU. And then if you have PP and zinc, we don't know, right? Consider, don't forget, PP and zinc.
Lead is less active than zinc.
Let's go to the table. I'm not going to tell you now. This is lead, PP, and this is zinc. Which one is higher?
Zinc.
Zinc.
So is this reaction take place or not?
Not.
No reaction. Is this clear?
Yes.
Yeah.
Good. Now,
Doctor, why no reaction here?
what again?
why SN
We said that already. Zinc is higher, zinc is here, and Pp is here. So zinc want to stay as zinc 2 plus, not zinc. So there will be no reaction. But these platinum and gold are very low, and that's why the fluorine, the iron want to become F2 plus, and chromium want to become chromium 3 plus. But zinc want to stay as, because it's higher, zinc want to stay as zinc 2 plus. Now, if you have a reaction, you must always if you want to write a reaction, okay, here we want to write the full reaction. Okay, write the full reaction now. The oxidation and the reduction. Let's take one of them, and the rest will be the same. Okay, let's take the first reaction. We have aluminum and calcium. Oh, they are very close to each other. Let's do C better. Stannous and hydrogen. Let's go to the periodic table and we'll find where is stannous. This is 10. Which one is higher, 10 or hydrogen?
10.
10.
This one. Let's write the oxidation for stannous.
SNI.
Sn goes to Sn 2 plus 2 electron. Is this oxidation or reduction?
oxidation.
What?
Oxidation.
Okay. Oxidation. So let's go for hydrogen. H plus goes to H2 gas.
Reduction.
This is reduction. How many electrons do we need? We need 1 electron to each one. But since we have H2 here, we must multiply this by 2 and this by 2 to make it H2. Now, if we combine them together, the 2 electron will go with the 2 electron, and what will be the net result? Sn plus 2H plus goes to what? Sn 2 plus H2. Okay? And the number of electrons, I must make sure that the number of electrons is the same. What do I call these two reactions together?
Oxidation and reduction.
Product.
What is it called?
Redox.
Redox reaction. Redox reaction. Is this clear? Okay.
Yeah.
Okay.
دكتور
Make sure that the number of electrons are the same in both of them.
دكتور
Yes.
ناخذ المركب ونكنسل العنصر اللي فيه الهيدروجين مثلا ايود.
No, iodine, nothing happened to the iodine.
تمام.
Iodine, nothing happened to it. Okay, let's very quickly do the other one, which is chromium and lead. In this case, let's do B. What happened to chromium?
Replace. BB.
Chromium goes to chromium 3 plus 3 electron. While for lead, the acetate will stay as it is, so there's no change in the acetate. But the lead PP, it was PP2 plus, goes to what?
PB.
PV.
P plus, sorry,
Minus
plus 2 electron there. Now, if I want to add them together, what should I do first?
Make sure both have the same electron.
same number of electrons.
This means what should I do?
Multiply the first equation by 2 and the second by 3.
Exactly. I multiply this by 3. This means 2 times 3 electrons is 6 electrons, and 2 times 3 electrons is 6 electron is gone. So the net result will be 2Cr go plus 3 pp 2 plus goes to Cr 3 plus 2 Cr 3 plus 3
PB.
P 0, and now it's balanced. Is this clear?
Yes.
Yes.
I hope so. Good.
Doctor,
Yes. Okay.
how you decide quickly that CR is going to be
From the table.
plus
From the-
3? Okay. It will be given in the exam, right?
I will give you.
Thank you.
Exactly. What do you call this reaction?
Redox.
Call this reaction.
Molecular.
Combination.
Why do you call it combination?
Because the nitrogen is combined with the
Two things
hydrogen.
make one thing. What do you call it?
Combination.
Combination.
And it's actually a redox reaction, because the nitrogen was 0, it become -3. The hydrogen was 0 because it's by itself, it become +1. So this is oxidation reaction. Clear? What do you call this reaction?
Decomposition.
Decomposition. One thing make two different things. Again, it's oxidation reduction. If you look at the oxidation, anything by itself is 0. And this is 0 and this is 0, but there is oxidation numbers here. Okay, these are called decomposition reaction. Okay, how about this compound here? We have O2. What's the oxidation number of O2 here? It's a special case.
-1.
It was -1. You remember? I'll go back to the beginning when I told you that oxygen is what?
Peroxide.
With hydrogen.
Peroxide is -1. Exactly. Very good. Peroxide is -1. And now, what's the oxidation number of oxygen in here?
-2.
And what's the oxidation number of oxygen here?
0.
So nothing happened to the hydrogen. There is no oxidation or reduction to the hydrogen. The only thing that has been oxidized and reduced is oxygen. We call this reaction disproportionation reaction, because the O2 minus 2 actually went to O2, O minus 2 and at the same time the O2 minus went to O2. See what happened? The oxygen, what's the oxidation number of peroxide here? It was -1. It became here what? -2. What's the oxidation number of peroxide here? Is also -1. What is it here? 0. 0, because it's by itself. Oxygen by itself. So the oxidation and the reduction took place only for the same element which is oxidized. We call this reaction disproportionation reaction. Disproportionation reaction. I want you to memorize the name, disproportionation reaction. And what is it? The reduction and the oxidation will take to the same place. In previous reaction, always, what has been oxidized here? The hydrogen has been oxidized and the nitrogen, the sodium has been reduced. And here, before, the nitrogen has been reduced and the hydrogen has been oxidized. But in here, only oxygen has been reduced and oxidized. This is called disproportionation reaction. And with this, now, let's talk about molarity. Molarity, all right? Molarity, what is molarity? Molarity is something we use to know the concentration, how much of the material is available. What is molarity? We say that this solution is concentrated. I want you to memorize the word. What's this solution? Concentrated. This solution is diluted. What's diluted means?
Not concentrated.
Not concentrated. مخفف. What's the meaning of concentrated in Arabic?
مركز.
مركز وهذا مخفف. I want you to memorize the word concentrated and diluted. How can we make something concentrated, diluted?
By adding water.
Exactly. Add water. Add pure water. Clear? Good. What is molarity? We define molarity as such. It is moles of solute per liter of solution. What is moles of solute? Number of moles. You can calculate moles? Hello?
Yes, we can do that.
Yes.
Good. All right. Let's solve this problem very quickly. So molarity, we are going to use the big letter M. When you see this big letter, what does it mean? Molarity. I want you to calculate the molarity of 2 liters of solution that contain 50 grams of glucose. Glucose is C6H12O6. So I want you to calculate molarity. Go ahead. Quickly do it in your calculators. We know that carbon is what? 12.01. Look at this. Hydrogen, 1.008. Oxygen, 16.00. Go ahead, calculate the number of moles.
Uh, 0.02.
What's the total mass of glucose?
180.2.
Exactly. Yes, I know this. 180.2. Very good. 180.2. 180.2. So what's the number of moles?
0.28.
0.2.
28.
0.28. Exactly. Good. What's the molarity?
0.13.
0.14. How come? This by the 2 is 0.14. Exactly. Is this clear? Good. We want to know what's the volume of this solution. If we know the molarity now, and we know the volume is 0.250, then how many moles are there? What's the volume? We know molarity is what? moles over volume. So if we know the molarity and we know the number of mole, the number of mole, 0.250, then what's the volume?
Divide by the molar.
Divide by
5.250 by 0.14. What's the answer?
1.8.
1.8 liter, exactly. 1.8 liter. I hope it's clear. Okay, last thing. The number of moles of glucose in 0.5 now, again, we have M, which is equal to 0.14. We have the volume as 0.500. Then how many moles are there?
zero 0.07.
0.07, exactly. Is this clear? I hope so. Now, if you are doing dilution, what does dilution mean?
تخفيف.
تخفيف. All right. Then the rule is you multiply the molarity times the volume that you have for concentrated. This equal to the molarity of the diluted times the number of liters of the solution. Is this clear? I want you to memorize this rule. MCLC equal to MDLD. I want you now to read it. Read it. The molarity, what?
Of concentrated
Times the volume of the
concentrated
equal to what?
the molarity of diluted times the volume of diluted.
Okay, good. Okay, let's do this very quickly. What volume of 12 molar HCl? So we have MC is equal to 12 molar HCl. Commonly must be used to prepare 250 milliliter of 0.125 molar HCl. So we have MC and we have this one as MD and this is LD. So what volume is needed with 12 molar HCl to prepare 250 milliliter of 0.125 molar HCl? We have LD and we have this is the, I want to prepare 250 milliliter, so this is the volume, and the molarity is 0.125 molar HCl. So what will be the LC?
2.6 milliliter.
Now look, 2.6 milliliter. Okay, and is this a right unit, milliliter? Yes, because this is milliliter, this must be also milliliter, because the molarity will go with the molarity, and the only thing that will be left is the number of liter. Is this clear? All right. Now, if you are in the lab and you have the molarity of this compound, the molarity is 12.0. And you know that in order to prepare 250 milliliter with the molarity of 0.125 molar, I need to have, what's the volume? LC, we did it already.
2.6.
So if you go to the lab and I give you only this compound, I will give you a bottle, and I told you in this bottle here, I have HCl, and M for this HCl is 12.0. So how can you prepare this compound? You bring a beaker and you take how much of this compound?
2.6.
Exactly, 2.6. Exactly. Then how much water you add to it to make this compound?
250 milliliter.
Are you sure 250? No. You
For
should add
water, I don't know.
250 minus
2.6.
exactly. So how much should I add to it? Only 247.4. Is this clear? Do you know how to prepare it now?
Yes.
Yes.
I hope you are able to do it this way. All right. We can do this with serial solution like this. So we can, if you have concentrated solution like this, and you want to make it less and less and less concentrated, what should you do? You should, as I told you, for example, if you want to do it this way, you have to take certain amount and then add water to it to make it with this concentration. Let's do this very quickly. If I have stock solution, this means available in the lab, it is 2 molar. 2 molar, okay? And I want to prepare 250. Okay, I took this is MC, of course, at this time, 2 molar, all right? And I took 10 milliliter, and then I made it to 250 milliliter. What will be